Okay, so in this exercise, I would show you how to draw a contour map. So this is a function f of x and y, which means z as a function of x and y, and this function is a cardinal sinus of x2 plus y2. Okay, so mathematically, it means that this is, you know that sin c is equal to sin x divided by x. And in 0, it takes the value of 1 by continuity prolongation. So we're going to write a function f, we'll call it my f, and in this form. So, okay, so def my f of x and y, and this my f, so takes, so maybe before this I can put here my libraries that I'm going to use. So, and in the calculation, it should return z equal to np dot sin c of x exponent 2 plus y exponent 2, and I should return z. So this is my function. Now I would like to draw this. So I would say that I will use in this case the function contour. So before this, so this is my first step. Maybe I'm gonna do it like this. Okay. Okay, let's define x equal to np. So I'm taking just a clean space, a small vector for the test. So from 0 to 5 here, okay, to 5, take 6 values. Similarly, y, okay, because this is the domain of y, and I'm gonna print them. So print x and y. Okay, so let's run this. And these are my vectors, okay? So this is x and this is y. So as you see, these are linear vectors. If you have this, if and you want to draw your function, mathematically a function is like this. Z, a function of x and y. So normally you have an x-axis like this, okay, a y-axis and a z direction, z value, okay, and normally x would take a lot of values here, okay, and same thing for y. So in general, what you need is a mapping of the plan, okay, a grid where, for example, a point here is defined by xi, y, g, and not a vector. For that, with these values, in reality, you need to create a grid. So what I'm going to do is the following. So I'm going to write x, y is equal to np dot mesh grid of x and y. And maybe if I take here, just to make it different, if I take here 4, okay, let's run it again. So no, maybe, okay, I'm gonna take 11 value, just to make the difference, just to make it visible for every one of us. So these are the vectors x and small y. The capital X and Y are like this. Print capital X. So this is capital X, okay? It's a mapping, okay? So these are all the values in the plans for X, Xig. If you take this point and the point in the same line of X, they have the same value of X, okay? Same thing here, same thing here, same thing here, okay? And this value have the same, this line have the same value of Y. So they create a mapping Okay, so same thing. If you print y, you have the same logic, capital Y. Talking about the grid, the mesh grid. So okay, but it is horizontal in this case. So now if you create this mesh, you are able to do the calculation for Z. So in this case, I'm gonna write that Z is equal to my F of capital X and Y, okay? And when you run this, you obtain a matrix Z. So if you print Z, look, this is capital Z. And each value of Z is obtained as a result, okay, of the calculations of NP's cardinal sinus of x2 plus y2. And it works. I'm gonna delete all these prints, okay, and try to plot it. I'm gonna delete this, print y or print x. I'm gonna delete all this, okay. Okay, I don't need this, I don't need this. Okay, so now I'm gonna write PLT, for example. I will start like this, PLT figure one. I would draw in separate things. So PLT dot, and I will use the function contour. Okay, there's a contour and contour fillet. I will use in the first case contour. So X, Y, Z, and this is the default. If you run this, this is your result. Okay. Now I can increase because I have small numbers. I can put here, for example, 50 videos, and here 40 videos. Okay, so if I run this, okay, this is my result. Okay, certainly if you put a lot, if you put 200 by 100, for example, the result is smoother. Okay, you will have something smooth, and it is something. So in this case, it's smoother because you have a lot of points, and we can also create a figure two. And in this figure two, I can use the figure two. Can use the command contour F fillet. So in this case, you have this and you have this, and you can play even with the color. So if you put here, for example, the option colors equal to black, the result would be like this. Okay. You can also specify the number of contours. So after Z, you can specify that I have 20 contours, for example. Okay. So if you run it like this, you have, and you can then you have 20 contours in your calculator. You can add more. You can have 100 contours. Okay. Well, you will have something like this. I'm gonna keep 20. It is red, but we're gonna verify the options here. So just do help. So you have two options. You can go to plt.contour and go for help to see the different options, or you can go to the website directly. Okay, and look here, you can find a lot of options. So for the color map, or for the color, we're gonna see what are the possible options for the colors. Okay, so we should verify this. So we can look for the details about the contour in Matplotlib for this kind of details. So if you keep the default, you have something colored, but I think you can change this. You have a lot of options. So this is what is needed in this question. So use the function contour, contour fillet. I think there's a lot of other functions. So if you disable this and keep it as a default, I can remove this one. Okay, so this is the default, but we can find better than this. Certainly, if these colors, if you don't like these colors, you can define, you can come, for example, here or up, you can define a list of colors like this, blue, green, like this, and use them here, for example, color equal to colors. I should verify this syntax, maybe colors, okay? So like this, you have a series of colors. So as you see here, the magenta is in the majority. You can play with the different colors, change them to be suitable with your. If you use the function contour fillet with the same option of colors, you can do like this. Okay, and you have this kind of details. So certainly, as you see, the majority is of the colors is between. I can add also here 20 contours, so you find this kind of details. But I think you can find better. There's another library called Seaborn, and if we install of this library, we can import the color palette of this. There's a in the CMD. If we install Seaborn, this library will permit you to use a certain. It is already installed with me, but if you install this library, you can use it, and you can even look for the literature about the library Seaborn. Okay, you can look for the Seaborn library. Okay, okay. So it's a library for visualization. It's a nice library that completes. Okay, so data visualizer based on matplotlib, but you have additional information how to use it, especially for the use of colors, uh, because it's more convivial and you can use it. So in your there you can find a lot of example and details here, okay, for the different kind of situations, and you can use also the color palettes. Okay, so you can use this kind of color palette or this one or this one. So it is nice in terms of uh, type of colors that you can use. Okay, this is we can choose, for example, different type of color palette, and you can insert them in your drawings, in your figures. So, for example, here, if we would like to use this kind of colors in my contours, I can copy this, okay, and go back to my assignment, and I'm gonna go here and import Seaborn as. In general, they import it as SNS. So I'm gonna import it like this. And here in my colors, I will not use this color, but I will use that color. So my colors would be, okay, like this. Okay, I can comment this. So if I run from the beginning, okay, uh, sorry. Okay, so I'm gonna get this kind of results, and I can change the results according to what I would like to see. So here, because I have eight levels, but I can put it to 10 or maybe 20 or 15. Sorry, 15. So if I run it like this, so this kind, I get this kind of results. Okay. So you have a lot of other options. You can use this one. You can use this option. Maybe you can use the color the color palette paired. Okay, you have other kinds of color palette that you can use. Uh, tab 10. All these are predefined. Okay, so in this case, color palette here, I'm gonna put tab 10 and run. Okay, so this I have this kind of result. So this is mainly what I would like to say concerning the contours. Why I'm talking about this? Because later on, when we will draw, imagine you have a road. Imagine you have a road, and this road is in this road there's traffic. The traffic is generating a certain pollution, and this pollution is transported by a certain wind U. So, okay, and so this pollutant will create contour maps. Okay, these contour maps will represent the level of pollution in your study area. For that reason, we are looking to this kind of exercises. But certainly, if you print Z, if you can print the Z, okay, Z is a matrix, and for any value of X and Y, you have a level of pollution or anything. Look, these are the values. Okay. Okay. Thank you. Another thing, last thing. So we can also add PLT dot. For example, okay, I can add it here, color bar. Okay, here in the figure number one, Control X. I'm gonna put it here. Okay. So if you do it, you have a color bar, okay, with different graduation. You can add it here. In this case, we have something filled, okay? You have something like this with the different levels. You can add your title. You can add everything you want. It is similar to what we seen before with the function plot.